Hey, what's up guys, my name is Nasir and today I am going to teach you how you can make your own automatic hand sanitizer that detects your hand and dispenses the sanitizer for you without touching it. So let's go! Okay guys, to make this project we will need an Arduino Nano as our microcontroller, a servo motor to press the sanitizer, and I use this one because my sanitizer requires a lot of force to press it. You can use a small one if it is easy to press. And a breadboard for connecting all the components. I use this tiny one because it is the perfect size for the Arduino Nano. Makes it all easy. For hand detection I have used the IR sensor. You can use any other rain sensor and I have used this one because it's very simple to use. You will need a small piece of thin wire. This will be used to pull down the sanitizer press. And you will need a 5-volt battery. I found this one in a power bank. You can use any other battery, just make sure it's 5 volts. And finally the hand sanitizer. Please make sure you are using the same type of container that is used here. First you will have to do 2 holes across the center of your sanitizer cap. You can do this by heating up a needle and then punching it through the sanitizer cap. Make sure that the holes are across the center because if they are not, the sanitizer cap will not come down. Take the wire and put it inside these 2 holes as shown here. Bring those 2 ends of the wire at the front of the sanitizer and they should be in such a way that when you pull them down, the sanitizer cap should also come down with it. Then you have to take your servo motor, apply some hot glue on it and then attach it to your hand sanitizer as shown here. Make sure you glue it properly or it will come off because the servo motor uses a lot of force when it spins. While connecting the servo motor to the sanitizer, make sure when you spin the arm it spins outside and away from the sanitizer, not inside the sanitizer. Take the 2 ends of the wire through the servo armhole and tie them together tightly in such a way that when you spin the servo down, the cap should come down with it. Apply some hot glue on the knot to make sure that it does not open or loosen up when the servo moves down. Take the IR sensor and glue it right below the sanitizer cap as shown here. The LEDs of the sensor should go to the front and the pins should go to the back of the hand sanitizer. Take the mini breadboard and connect the Arduino Nano with it. Use the jumper wires to connect the IR sensor and the servo motor with the Arduino Nano. Finally, connect the battery with the Nano and the circuit should look something like this. Connect your components as shown here. Connect the power and ground of the IR sensor and the servo motor to the power and ground of Arduino and used any 2 digital pins to control the IR sensor and the servo motor. I have used digital pins 11 and 12. Finally, connect your battery with the 5-volt and ground of the Arduino as shown here. If you are using a battery with the voltage of more than 5 volts, then connect it to the V-in pin instead of the 5-volt pin. After you have done the connections, just glue everything up at the back of the sanitizer and it should look something like this. You can use a zip tie to reduce the mess of excess wire. Finally, if it's all done, it should look something like this and then all you have to do is upload the code. Okay guys, so the code for this project is pretty simple. First you have to include the servo library because of course we are using the servo and this library makes it very easy to use the servo. And next thing, you want to declare this variable interval and I will show you in a bit at how it's working and what it's doing, but just know that this variable is responsible for setting the delay for which your hand has to be in front of the sanitizer. I mean, for this time, if your hand is in front of the sanitizer, then your sanitizer will dispose the sanitizer for you. Well, that's a lot of sanitizer in one sentence. Okay. And this variable current millis is actually, this will actually store the value of current milliseconds, and again this previous millis, just like that, will store the value of previous milliseconds. I will show you in a bit that what it's actually doing. And this variable is just storing the what pin you are using for the sensor, and I have used pin 12, so sensor pin is pin 12. And then you have to create the object for my servo, and if you have already used the example for the servo, then you should already know what it is. I mean, it's pretty simple. Okay, so next is the setup function. Here we will first set up the pin mode for the sensor pin, and of course it will be input since it is detecting the hand, so sensor pin on input. and then this my servo dot attach 11 is actually attaching your servo to pin 11. Now this actually, oh, it's not 12, it's 11. So what this function is doing, that it is telling the Arduino that use this pin to use the servo, and it basically sets the those PWM signals, or allows the Arduino to set those PWM signals that are used to drive the servo. If you know how the servo works, then you may know that what it's actually doing, but just know that this functions allows the pin 11 on the Arduino to drive the servo. I will make another video on the servo alone, but for now just know that this function is allowing the Arduino to use the pin 11 to drive the servo. Then we use the function myServo.write. This function actually controls the servo. Now first we allow the servo to be controlled, and then we are controlling the servo, and we are telling it to move to 180 degrees. Now the servo I have used is 180 degrees, so when I write myServo.write 180, it will move the servo to 180 degrees, and for me 180 was the neutral position where the sanitizer was not being pressed. So this is like the normal position for my servo. So if I write 0 here, my servo will come down. If I write 180, it will go up. So yeah, that's what it's doing. So that's all for the setup function. Next we are moving to the loop function. Alright, so in the while loop section we have the first line of code as an if condition, and this condition is basically detecting if there is something in front of the sensor or not. And this digital read function, digital read sensor bin, will return you the value of 0 or 1 depending what was the state of the sensor. So like if the hand was in front of the sensor, then the sensor gives you a 0, so the digital read function will also give you a 0, and we compare it to our 0 that we put there in the condition, and yes, 0 is equal to 0, so this condition will give us a true. So this condition is true, yeah, and once it is true we can go inside it, and then we have the next line of code as current millis is equal to millis function. So now this function is basically, there's a timer inside Arduino. Whenever you power up your Arduino, this function starts running, and it goes like, when you started the Arduino, time was like let's say 0001 milliseconds, and after 1 second this function will give you 1000 milliseconds. After 5 seconds it will give you 5000 milliseconds. So like that, this function is just basically giving you the time of how much time has passed since the Arduino is running, that's all. And we can use this function to do a lot of things, like this literally is used to put delay without using delay, and that is a very amazing thing, and I'll make a video about it. I'll make a video about that, but just know that this function is returning the time that has passed from the start of the Arduino, from when the Arduino was powered up. Okay, so we have another condition after this, if current millis minus previous millis is greater than or equal to interval. So current millis, let's say 10 milliseconds have passed since the program has reached this line of code, and previous millis we have declared it as 0, and interval we have declared as, let me check, I think it was 700. Okay, 700. So let's say it's 700. So 10 minus 0 is not equal to or greater than 700, so this condition is, right now this is false. So let's write false here. So like in 10 milliseconds this condition was false, and this whole block of code will not run, and we skip this one. The next line of code is else, because the if was running, the else will not run, and again we go back, since it's a while loop, this will start running again and again and again. And then again we have the if condition, and the hand is still in front of the sensor, so this condition is still true. But now what has changed is that, let's say time has passed up to 20 milliseconds now. So 20 minus 0 is, okay, not 700, but keep in mind the time is changing now, time is increasing. So again everything will be skipped, and the time will change. 30 milliseconds again skipped, 40, 50, and then 100, let's say 200. So after about 700 milliseconds have passed, and then if we check it, current millis are 700 milliseconds, and minus previous millis is equal to 0. So is 700 greater than or equal to 700? Yes, it is. So what we do is myServo.write 0. So what actually happened, We kept checking this condition for 700 milliseconds. And if the condition was true for exactly 700 milliseconds or greater than 700 milliseconds, then what we do is we tell the servo to move to 0 degrees. Now why I did this was this sanitizer will not work if I just rapidly move my hand in front of the sensor, like just whoosh. It will not work. So my hand has to be there for at least 700 milliseconds because the interval is 700 milliseconds. It has to be there for that time for the condition to be true. If it is not, it will not be true. So after this time passed, this interval passed, this condition was true, then the servo moved to 0 degree and we give it some delay to move to 0 degree and we wait. Once it has moved, we put the servo back to 180 degrees. So the servo is now back to its original position. So what happened, we put our hand there for 700 milliseconds and the sanitizer is dispensed and the servo goes back. Now what happens is that while digital read sensor pin is equal to 0, now we are actually waiting until the person removes the hands away from the sensor. So you should know that until whatever inside this small bracket is true, so let's say if true, or if it is 1, the code will be stuck here, the program is stuck here, it cannot move. So if the hand is still in front of the sensor, so this function will give you a 0, and if 0 is equal to 0, it is true. So until I move my hand away from the sensor, the code is stuck here, and exactly when I move my hand away from the sensor, it will wait 1 second to confirm, like give it a delay, and then it will reset the timer, because we have to update this value of previous millis, because yes, in the start it was 0, but after 700 milliseconds have passed, we need to bring it to the new 0, because now it will be 700. So that's why we set the previous millis to the current millis. I'll make another video on the this blink without delay function and explain to you how exactly this works, but just know that this is resetting the timer, so the next time you come, it is still 1 second and not just crashing the whole code or just dispensing the sanitizer if even something whooshes away from the sensor. Okay, that's all for the first if condition. And if the hand is not in front of the sensor, what it's doing, that it's just keeping the timers reset, so the previous millis will be updating. So like I don't put my hand in front of the sensor, and if the value was still 0 and the current millis was like 5 seconds have passed, so if I even move my hand away from the sensor in a very fast movement, it will still be true, because this value was not updated. It's a bit hard to understand right now, and if you don't know what this millis function is doing, it will be very hard for you to understand. So I'll make another tutorial very soon about the blink without delay example. You can try to learn it from here. Go to examples and digital, and the first thing there is blink without delay. So there's neatly explained example of how this function works, but more or less I will explain this later. But just know what it's doing here. It's just confirming that the hand was there for exactly this interval before dispensing the sanitizer. Hope you understand the code, and now let's upload the code and we're done. Okay, yeah, that's it. Okay, so after you upload the code, your automatic hand sanitizer should be ready. I've made a video with my friends to show you how this sanitizer can save your life someday. The link is in the description. Don't forget to watch it. If you enjoyed this video, please press the like button and subscribe to my channel. Thank you.